Know that if you do like 2 over 3 times 3, it's really like you're doing that. And then those would cancel. And you would just be left with 2 over 1, which is 2. Here on number 2, you multiply 3 over 5 by 5 over 1. Those 5s are going to cross cancel. And you're just going to get 3, or 3 over 1. Like here, what would we have to multiply by here to get the 13 to go away and make it just 11? And so it would have to be always the number on the bottom, because that way they cancel, and then you're left with just the one on the top. So like this one, always just multiply by the bottom, cancel them, and you're left with the one on top. So that's kind of what that part's getting at. Just like remember that the top one, you can cross cancel when you multiply with fractions. Is something like this. Oh, from 3 to 2, that goes down 1. From 2 to 3, that goes up 1, up 3, up 5, up 7. Okay, we did the first rate of change. That's not the same, so it's not that. The second rate of change would all be 2s. Because think about it, this is the part, there was a problem like this on the Ready, Set, Go. On one of the practice quizzes, that people were kind of confused here. Remember, from -1 to 1, that's still a jump of +2. And then 1 to 3 is a jump from +2, +2, +2. So this one should be quadratic. You guys should remember that, hopefully. So this part now. Plot the points from the table and draw the graph. Okay, so we haven't really done this a whole lot yet with the graphs. But all you're doing is plotting these points. So like this one right here is left 1, up 3. This one's over 0, up 2. Right 1, up 3. Right 2, up 6. Right 3, up 11. Right 4, up 18. And so you literally, when it says plot the points, you literally just, that's going to be a point, that's going to be another one, another one, another one, another one, another one, and then just connect them. Okay, there's going to be like it's not showing up right now because of the way that I have to, should probably do this. But if you look on your test, this is what your graph's going to look like. So you're going to have a grid. It's going to be labeled for you. Okay, and you just literally have to go plot all those points. So like we said, the first one would be -1, 3. So you would go always from the middle. Remember when we graph, always start in the middle. Left 1, and then up 3 puts us right, oh, I really got to zoom in for this. It goes by 2s. Puts us right about there. So that would be going left 1, up 3. That would be one of the points. Whoa, dang it. In the middle. And I think the other one was like 0, what was it? 0, 2. So then the next one would be right there. All right, and then you just make all of them, connect the dots. So 8 should be kind of like almost a free one, to be honest. Yeah. All right, then we get like recursive formulas. Okay, we talked about, oh, that shouldn't be on there. You won't have this on your test. Remember we said for quadratic ones, no recursive formulas. So you will not have to put this on your test. All right, but then the explicit one, so I'm going to go back up and kind of remind you guys how we did the explicit one. Whoa, that's not what I wanted. Okay, so if we know if it's explicit, if it's quadratic, I should say, that it's going to have a square in it, x squared. This is like the newest thing we did. Okay, so if you guys, that's kind of why I'm going over this one, just to make sure. We always start with x squared. Now keep in mind that these ones on top, those ones are the x's. Okay, so what we need to do now is we need to take one of those, any one we want. I don't like negatives. So, for me, I would probably start with this one. I'd probably start with a 1. And then what we want to do is we want to plug that 1 in for the x and see what comes out. Okay, now what should come out is the 3. But if I plug 1 into this, whoa, right in circles here. If I plug 1 into this, I'm only going to get out 1. So then we have to figure out, what do I have to add to 1 to get out 3? And the answer is 2. Okay, so that means when I go back to my equation, I had the x squared, that's what we started with. Well, to make it right, I have to put a plus 2 at the end. So it's kind of like, again, it's trial and error. You just have to know which one of these, you plug in the 1 and get out the 3. Remember, the x's are the inputs, the ones you plug in. We always plug in a number for x. We never plug it in for y usually. Y are the outputs. Okay, so when you plug in 0, you should get out 2. You plug in 2, you should get out 6. Plug in 3, you should get 11. 4, you should get 18. So that was number 7. 7 is just if it's linear, quadratic, exponential. I got you, Matt. You're good. And then when it asks you why, remember we talked about this. So I'm not even going to I'll say it one more time real quick. Linear, if it adds or subtracts every time. Exponential, if it multiplies or divides. And quadratic, if the second rate of change is constant. So those are your reasonings that you should be putting in here, one of those 3, for whichever one it is. All right, no recursive, and then you will have to do the explicit. So again, you just start with x squared and make the adjustment. All right, so here, oh shoot, hold on. Shoot. Sorry, it seems like it's kicking everyone out. Okay, so I'm going to try to finish this quick. All right, so now the domain of this, whoa, that was like a formatting thing. That was crazy. The domain of this is just going to be the farthest it goes left to the farthest it goes right. Okay, the range, how low to how high. All right. And so on these ones, when you connect these dots, remember when you graph these points and connect the dots, there should be arrows. Like the pattern keeps going both directions. We just don't know what it is. So keep that in mind when you're thinking about domain and range. There should be arrows in both directions. Okay? On both ends of your graph, I should say. So just keep that in mind. All right, then here's another one. Same questions. Okay, is the pattern above linear, quadratic, exponential? This one happens to be, let's see, this one looks linear to me. Looks like it's adding. Can anybody see what this is adding every time?
Three.
Good. So this would be, for 13, you'd circle linear. And for y, you'd put, because it adds 3. Then 14, again, you just plot all these points. Left 1 up 4, or left 1 down 4, sorry. Over 0, down 1. Right 1, up 2. Plot all those points. Good, Jose. And connect them with arrows, remember? Okay, then it asks you for the recursive formula. Okay, so remember, yes, this is review. This is review for the test. I'm going over the study guide right now. And there's going to be a screen recording on this on YouTube, so you can rewatch what you missed. All right, so remember here for the recursive ones, we have to write the starting point first. Okay, so the starting point is always just where the table starts. Okay, so in this case, it's going to be the first x is -1, the first y is 4. That we're given, at least. And then the next part, we write that. And again, this is going to be multiple choice on your test. So you're not going to have to write it. You're going to have to pick the right one. And then comes the pattern after that. So you guys told me on this one it's +3. Okay, so that would be the recursive equation. Got to write the starting point first. And then the rest of it also. Okay, the starting point, and then to get to the next one, what's the pattern? What do you have to do to get to the next one? All right, that's the recursive formula. We talked about explicit formulas for linear ones a lot already, so I kind of just put it in here. It's the pattern. It's always mx plus b. Okay, and then because it's linear, it's going to be mx plus b. The m, remember, is the pattern, and the b is the y that's across from the 0x. Okay, so in this one, I think the pattern was 3, so it would be 3x. And then somebody go back and look at the table. Oh, wait, Michaela's coming back in, so it's going to kick me out. What's up, Michaela? So if I go back and look at the table, normally we had to go backwards. We had to do the pattern backwards to get this one. But in this case, it's already on it. So this is our y-intercept. That number is our y-intercept. So we'd go back down, and that equation would end up being 3x, and then with a -1 at the end. So when you do these ones, remember, you just need the pattern, which is usually the first thing you see. And then that's the y that's across from the 0x. In other words, the y-intercept. So like here I put it, when x is 0, y equals what? And that's kind of what you're looking for on the table. Okay? The domain and range, again, how far left, how far right. Don't forget you're connecting the dots. So there's going to be arrows on both ends. Here's another pattern. This one's exponential. We talked about all this. There's a bunch of videos on this. This one, you're just basically filling in these tables here. So make sure you know how to plug in points. Okay, so on this one, x is 0. So here they want you to plug in 0 and see what comes out. So here we're doing 0 squared. Sorry. Here we're doing 0 squared. Here we'd be doing 1 squared, 2 squared, 3 squared. And obviously those aren't the answers. You have to square them, and those would be the answers. Okay, and then over here, now keep in mind that the x is going in for the exponent on this one. So this is going to be 2 to the 0 power. 1, oh sorry, I already messed it up. 2 to the 1 power. 2 to the 2 power. 2 to the 3 power. Remember, this number here is going for the x. That's what kind of confused me. 2 to the 4th, 2 to the 5th, and then that's it. All right, and then it asks you to graph and label them. So again, you would just whatever this comes out to, these would be your points. Okay, so that one would be 0, 0. This one would be 1, 1. This one would be 2, 4. This one would be 3, 9. This one would be 4, 16. This one would be 5, 25. So again, you just plot all the points, connect them.